Hi, I'm TimSpann, developer advocate for all things Apache streaming. Today we're talking about using the FLaNK stack with Apache Flink for different streaming use cases. So what is FLaNK and also my correlated stack of the flip stack? What's that? So FLaNK is Apache Flink, Apache Knife, and Apache Kafka working together. Flip is Flink, Apache Pulsar, the connector that connects those together, and some other Apache projects. We could throw NiFi in there, Tika, lots of different great projects in Apache we can use. That connector from String Native is open source and hopefully will let you do any kind of apps that you're looking for. Apache projects are the way to do all kinds of streaming use cases, and we'll show you that today. I wanted to get more into the Flip stack. That's Flink integrated with Pulsar using Stream Native's Flink connector. We could bridge between those two different streaming systems. Makes it very easy. I get data into a Pulsar topic, and then I could read it from Flink, and Flink can also push to a Pulsar topic. So you got both source and sync there. So wherever it needs to be in your streaming pipeline, you have that ability. It's not just source, it's not just sync. You've got options, which gives you a lot of power. Why Pulsar? Again, another great Apache project, open source, nice as cloud native, distributed messaging, streaming platform to do, almost everything you need to do with events and objects and data as it's coming in motion in a stream. Makes it very powerful, easy to use. A lot of features here. It's kind of a complex architecture, but when you use it in a hosted environment or in one of the Kubernetes brokers, pretty much runs itself using the command line interface to set it up. You write an app, whether you're producing messages, you're consuming them, use one of the client libraries. There's a ton of them, whether it's Python, Java, whatever you're looking for. Uses a service discovery because we could have a lot of brokers. If you've used Apache Kafka, get an idea of a lot of brokers. This one also has Zookeeper to help manage some of that state and some of the information that's got to be shared between all these different servers. What's different from Kafka is the broker is just the broker. It does, replication and client communication, dispatch, all those sort of things, load balancing, but it doesn't store the messages. This is an important difference because this lets us scale how many consumers and producers we're managing separate from the data. And what's nice with Apache Bookkeeper, these bookie servers have tiered persistent storage. So store it locally. You're not just required to install, run it, store your messages on a broker. It can be tiered out, stored into S3 or different object storage. Makes it very powerful, easy for you not have to think of, am I going to run out of space? What happens with this data? Am I sure it's persistent? And what another awesome feature really is geo replication. Again, with the cloud native architecture here, lets me run this regardless of how big my cluster needs to be, wherever it's running. I can run it in different availability zones and not really have to worry about trying to run some process to copy data between them or some manual setup. It's there for you. If you have simple processing you need to do with Pulsar on the data as it's coming in or going out, Pulsar functions make that very straightforward. And there's a talk today later by my friend David. He's going to go into that, and that should be really cool. That's right after this talk. So highly recommend you go to that one in the streaming track as well. REST API, again, something you expect from Apache projects and something you really need, to be able to see what's going on, make admin changes, do whatever you need to do in a simple manner. REST lets you plug that into DevOps tools, plug into NiFi. Lots of different tools can work with REST. Same goes with the command line interface. Makes it easy for you to do the basic administration and setup and different things that you're going to need to do with a complicated messaging system. Different kind of subscription types. It's not like Kafka where you only have one way to do it. And something kind of critical if you're going to use this in an integration environment. You know, I've worked at a bunch of customers, and you have a lot of legacy protocols out there for distributing messages, whether it's JMS, AMQP, or maybe you're doing IoT with MQTT, or you're doing Kafka, but you want to be able to, you know, replicate that between different architectures. Pulsar has protocol support for those. So it gives you one place to do messaging and integration, kind of a universal gateway for messaging. Very nice feature to have. Now, a big part of both of those stacks is Apache FLaNK. FLaNK is a project that scales up immensely. We're talking billions of data points, millions of events, millions of things happening real time. You run machine learning in there, real-time data pipelines that is complex as you need to be, and unify that stream and batch for data event processing. Very powerful there. And ton of connectors you need for doing things with HDFS, Pulsar, Kafka, object stores. You get that. What's nice, a little separate from, say, something like Apache Spark, which is great as well, is that it is true event at a time. You know, it's not a micro batch or a simulation, and it provides for the ability to do stateful or stateless operations, which can be very powerful. And being able to store that state along with Flink and various stores can make things very performant for doing aggregates and processing that needs to know what happened before. Again, stateful processing and streaming is something that happens. What's nice is the compute happens like Spark in memory, so you could scale it out very easily, add more nodes with more RAM, more processors, you'd get more done. Flink supports a very rich SQL thanks to one of my favorite projects, Apache Calcite. It gives you a standard ANSI SQL 92 to be able to run complex queries, so you're not limited to just a select from. There's joins, outer joins, functions, everything you expect to see in a real relational database is in this SQL. And it'll run on Yarn, Kubernetes, different environments. Again, a nice thing to run in whatever cloud you have. Makes it very friendly for Flink and Pulsar to work together, whether they're in the same environment, same availability zone, same cloud, or different. You know, that's the power here. As long as you have your security set up and you can connect between different environments, you're set to go. Flink SQL, I use that for a ton of applications. When we say streaming analytics, I'm not waiting till it's in its final store or even in its final state. Maybe I'm getting raw JSON data. I can query that with a SQL statement that's always running. So another event comes in, that shows up in the results, and I could drop that to a sink. I could push that into another Kafka or Pulsar topic, put it in a final data store, do some analytics on it, functions, machine learning, whatever functions or libraries you've built up in there. Be able to do continuous ETL or ETL processing on that. So you get the data, change it up, and then by the time it's downstream, it's converted for you, event at a time, really quickly. There's also some advanced semantics in that SQL for doing complex event processing. CEP is powerful, but can be pretty complex. Having that ability to do that in SQL makes that easier. And having this be extremely scalable helps out. So even though maybe you start off on your laptop or single Docker container, you could scale up to thousands of nodes on any different cloud or environment. Makes it very powerful. You learn it once, scale it as big as you need to. I've got an article in there for an example of using one of the tools that makes Flink SQL a little easier. So this is example architecture I have. All different types of data, anytime, anywhere you need to run it, multi-cloud, multi-protocols, whatever it needs. This is a good way to do this. Kind of a mix of Flip and Flank. which sound cool together. So say I have data, it could be text, could be XML, JSON, comma separated value, Excel, documents, images, S3 buckets, SQL databases, Mongo, stuff from Hadoop, Avro files, IoT sensors. You get the idea. There's a lot of types of data, whether it's coming from a log, coming from different services, whether it's cloud, on-premise, legacy, messaging systems. I get the data. Now, FLaNK and Pulsar have ability to read that data from the sources. But if I want a universal way to grab almost any data type, even if it's binary, even if it's data I may not fully understand, NiFi is the tool to easily grab from hundreds of different sources, ingest them, merge them, validate them, maybe convert types, maybe do some simple SQL, again with Calcite, get it in the format we need, push it along with as an event into Pulsar or Kafka. I can run some machine learning with, say, Apache MXNet, do some natural language processing on those text files or documents with Apache OpenNLP, or convert and pull out parts of, say, there's an Excel or Word document, it's got an embedded table, and I want some of that data out of there. Tika can read pretty much anything, get me any kind of data. I've got a processor for that in NiFi. It makes it very easy to turn documents into live objects, into events, into things that I could use to make real-time decisions, whether that's happening on an edge in, say, a NiFi, Minify agent, or on a server somewhere, anywhere on any of the cloud services. And then I get this into Pulsar. I can replicate this around the world, drop this into different storage through simple tiering or through complex processing with FLaNK, and then make it available to whatever analysts, data scientists, application developers, whoever's needing to have this data, write apps, whether that's in from static stores in regular tools or in Jupyter notebooks or Apache Zeppelin notebooks, or maybe it's continuous SQL and I'm pushing that to a REST endpoint and could use that pretty much anywhere. Most tools, whether it's front end apps, websites, mobile phone apps, can interact with REST, and that makes it very powerful. I have links to more content here. So you want to see articles, you want to see examples, source code, all of that is here for you. Makes it very straightforward. But you probably don't want to just see slides. I'm hoping not. I'm a big fan of showing live code. So what I have here is Apache NiFi, and I'm going to go into an example application that I'm using to gather data from a couple of different sources and process this as we mentioned. So this is my example application. What I have here is an HTTP endpoint. This makes it very easy for me to accept any REST call into this system. So what I'm doing is I have a Raspberry Pi 4 with some sensors sitting on my desk over there, gathering temperature and energy ratings and lots of data live every few seconds, reading what's going on in my office. And then on the other side of me, I've got a NVIDIA Jetson device that's running some basic analytics and also running a camera facing me down here, gathering data. They're both calling into this REST endpoint on that base and on that port and just sending in data. And I'm going to sort it out depending on some of the metadata that comes with it. What's nice with NiFi is that it always tells me everything going on. And this is data we call provenance or lineage that could be fed to a system like Apache Atlas or just stored somewhere, maybe putting Grafana, wherever you want to put data that tells me everything that happened about my event. So this is the birth of our event. The data happened, came off a sensor live, came off a camera, came out of a log file. Data's born. It has a starting date. Here we've added a unique ID to it. We know the size of it. And I know some metadata. This is the REST call that came in. I also passed in an extra parameter to tell me this is SCADA data. So this is some of the sensor readings and the contents here, and I could view that to see what's going on. And I've got a bunch of different types of data here. This is 100K. This is probably an image. Yeah, that's an image coming off the NVIDIA. And this is some processed image that went through deep learning libraries. Again, NiFi doesn't care. And then here I can route that data to different modules to process that, letting me do my programming based on what type of data it is. So I've got that Raspberry Pi 4, and I've got that Xavier NVIDIA device. I'm going to send them to different places. And we show you some of that data coming in. What I'm doing with the NVIDIA one is pretty simple, but it's pretty cool. So here you'll notice this one has stopped. And that stopped because I chose to stop it. What's nice with this is it doesn't really matter. I could stop things on demand, and when I'm ready, restart them. These are configurable queues where that can be load balance, can have priority, makes it very powerful to do whatever I want. And I could see what happens. Some of the data is just a static run log. Not very important. I don't really have a use for it, but I might use it for auditing. So I'll save that data in case someone wants it. I've got some that's images. If it's image data, I'm going to send that to a deep learning processor I wrote in DGAL that uses Apache MXNet to figure out what it's doing. See, here's an image. I can download that image, do whatever I want. NiFi doesn't care that it's binary. I could send that to a processor that works with binary data. If it happens to be JSON data, I send this to a query record processor that uses Calcite to run SQL queries against it. My SQL query is pretty weak, but I could examine any of those fields and make a where clause. I could select different fields from that I want to work with, maybe do aggregation, maybe do ordering. Up to you. Here I'm keeping it JSON, not making any changes, but I could stop that and convert it to something else. So you see here when it's done, I'm sending it to a Kafka topic. Got a topic called Xavier, just to give you an idea. That's all I'm doing with the data coming off of that NVIDIA device. I could do more. I have those images. I could send that to different processors to do more. Again, it's whatever your deep learning or whatever you want to do with images. Maybe just drop them in storage or Glacier, whatever. So I've got a bunch of data. Again, I paused it here so I could show you a bunch of data happening at once. This is that data for coming off that Raspberry Pi. And I could choose to run it just once just to have a little bit of data coming through. If I'm doing some debugging, I can go through the provenance, see everything with the data, all the attributes. I could see what file this came from. So this was from a log on the Raspberry Pi. And I could just release it, have everything start running. And then by the time I refresh the screen, we processed a few thousand records. This is a local NiFi running on my laptop, just to show you what you can do. I could have run a small cluster here, could have ran it in this office in a different cloud, wherever it needs to be, as long as I have network connectivity here. Again, I'm going to push that data to Kafka, can push it to Pulsar, wherever I need to push it. Here I'm doing a little query, a couple different ones, checking temperature. If the temperature is high, we have parameters here so I don't have to hard code things. So the query here is pretty simple, but it's making sure that it's a float and checking the temperature over 70, getting a little warm in here. I'm not going to do anything with those alerts right now, so I'm just going to get rid of that. Very easy to get rid of data. Here, I'm going to take that data, break it up so it's individual records. Sometimes JSON data will come in thousands at a time. I want to just break it up because my MQTT broker needs pretty small records to work with. So I'm just going to send them to my MQTT. And as you see, I published 4,000 records very recently. And I'm pushing some to a Kafka topic. Again, I could push it to Pulsar. I could push it to any cloud native messaging or JMS, whatever makes sense. So that data is now sent up to Amazon cloud somewhere. And as you can see, that came in from MQTT, came in from Kafka. If you look at the file size, you see that difference. MQTT, I split it up into smaller records. So there's 4,000, but it's 3 megs. Here in Kafka, 233, 3 megs. You get that idea. I also send it to an HTTP gateway directly from that device. And we have here another router, which I stopped. This looks at the data and decides who's processing it and how. So we can start running that. As you can see, records process really quickly. I add some extra metadata to tell me where I want to write this to, you know, what table names, schemas, that sort of stuff. So I can have a generic processing there. So here I'm writing a few thousand records to different Kudu tables. Apache Kudu is a very fast data store with Apache Impala on top. Makes it very easy for me to send real-time data there. As you see, I just processed a few thousand records pretty quickly. And this is on a 1-node cluster. Obviously, in production, you probably want 3, 5, or more. Here, I'm sending it to different Kafka topics based on that data that's coming in. So if it's energy data, send it to one place. If it's sensor readings, send it somewhere else. So we get that distribution pretty straightforward. How do I know what's going on with that? I need some kind of messaging display. This one's showing me Kafka. I have another one for Pulsar, and I could see those various events as they come in. One topic where I have data is the energy one. We were talking about energy. So we'll take a look at that. And I could see in the last bit, a bunch of data came in, and I could take a look. That is JSON data. I could see the various sensor readings on there. Makes it easy to see what's going on with this energy monitor. And then I could go back to that SCADA reading. I could see I've got, 11 megs of data in there and 30 came out already. You could see the different sensor readings, temperature. Ooh, that's pretty high temperature. Might need to turn the air conditioning on in this office, but it's making a lot of noise. Don't want to interrupt the recording, but the computer's suffering. At some point, I've got code on that device within that agent. If the temperature gets above an unacceptable rating, it's going to turn on a fan. If it still isn't enough, then the next step is it's going to shut itself down, and then I'll stop getting data, and I'll be able to see that in alerts because it just got too hot. That's going to happen based on temperatures. Now, if I want to send alerts, I could have alerts in case anything goes down with my infrastructure, or if no one's consuming the data, or if maybe I'm running out of space, all those sort of things. I could see there's some lag here on the two readers that are in FLaNK. So I want to make sure that my job is still running here, and we'll check that out, make sure we're getting data. If you look here, pretty straightforward code. Let's see if I make that a little easier to see. I'm not sure which is better for you, but if you look here, I'm doing a select. This is continuous SQL. As you see more records pop in at the bottom. What it's doing here is selecting from 2 different tables. These are virtual tables to make the SQL syntax make sense. I'll show you what energy 2 is, and I'll show you what SCADA 2 is. These are the topics that I joined together that have that real-time event data as it pops up. You can see more data coming in. And I join them. Here, it's just a simple join. I could do a full outer join. I could pick different fields. I could do aggregation. There's a lot of different things I could do here with FLaNK SQL. Here, I don't have it going into any sync, but I have a materialized view. And a materialized view is a way that I can have a REST endpoint against that data as it's coming through. Here's just some job details, and we'll go into the FLaNK dashboard to see what's going on. You can see the history of what I ran here. Also, I could see the different providers. I got Kafka, Kudu, a schema registry. And over here, I've got a materialized view. And that lets me provide a URL that I can integrate with another system, which I've done. So we've shown all this cool stuff. I go into the console. I could see that job I was running before. I can look at that job, see this materialized view, edit it if I want to change the name or the pattern, the fields in there. Maybe I want to add a filter, if this field equals something, then do something else. Pretty cool stuff there. I could also see all the different tables. We were doing energy. Energy here is defined as these columns plus this automatic event timestamp added. Here's the DDL to create that against a Kafka broker, and some different things like format and topic. And remember that the consumer group reading, pretty straightforward. Same with SCADA. I could see there's already one based on the schema, but I have one here for JSON, and that puts it in here. Makes it pretty straightforward to work with. I have that FLaNK dashboard to show that job that's running. This job here has been running almost 4 hours. It can be running for 4 months if I need it to be. So what's cool here is I can see where this data is coming from. Here's that one Energy 2 source table. Here is the SCADA 2 source table. And then here I join them together, get that resulting data, and you can see the different rows, how many received in each one, give you different metrics, see if there's any errors, see what's going on in the system. Lots of different things going on, some automatic checkpointing to HDFS. So if something goes wrong, you can restart it. Very powerful feature there. This is the results of calling that REST endpoint. And this will keep changing as the data changes. So if I want to integrate this with a mobile app, I want to integrate this with a regular web program or a notebook. I've got an example here where I'm using that from REST call from a Jupyter notebook. This is simple Python 3 little example. Just use the standard request to get it. Now that I've got it as a JSON array, I could turn it into pandas, make a table. Now my data scientists can get to this data, at a point in time. Makes it easy for them to start using that. We mentioned I was storing it in Kudu. Again, I could have stored it in any data store. Between Pulsar, Kafka, NiFi, and FLaNK, pretty much any data store you have, there's a connector. There's some open source way to get that into that data store. So, you want to have that data available for queries. It's right there. Same thing for the other table I have for those sensors. And we could sort and do whatever we want to do with SQL, whatever makes sense there. You could also do little visualizations using different visualization tools. Lots of options there, regardless of what tool you choose. Either connect to Kudu, connect maybe to Kafka or Pulsar, or through other means. Lots of options. I am very eager to get questions. I may or may not be on the live chat. I'm hoping so. The timing, me being based in East Coast US, makes that a little tough, but I'm going to definitely try. If not, feel free to contact me here, whether through Twitter, LinkedIn, go to one of my websites. I definitely want to dive deeper into what you can do with Pulsar, what you can do with NiFi, what you can do with Kafka, FLaNK. Lots of cool things you can do with Apache streaming, and it's not that hard. You start off simple. Use the basic tools that you can with at the first step. So like first thing I would do is, maybe simulate the data, get a couple of records. NiFi will let me simulate that data, with a couple of random values. So I know what it's supposed to look like. Get one record in, start looking at it, and then, go to the next step. What do I want to do? Do I want to send that somewhere? Do I want to send it to a database? Do I want to send it to something in the cloud? a blob storage, a database, JDBC, something like Elasticsearch, whatever makes sense for you, Hive. So many different options here, and they're all pretty straightforward. Lots of different types I could push it to. Very easy to store and manipulate the data using these different open source tools. Now we mentioned this within here. Let's see if we've caught up with the data. You can see that lag is gone, and there's a couple of them waiting for data. I've turned a bunch of these off so that if they're not doing anything, they're just waiting around. Like this one is a Kafka Connect app. I turned that off. We should check this one and see why he's slow. Make sure that this one is still running. Here's the producer. There's no one consuming it. That could be the issue. And we could take a look at that consumer group. Make sure we didn't change the name. Sometimes I change the names on these, and you'll have something like this happen and you don't realize it. When you're running these things within FLaNK SQL, we named it. So we were looking at that SCADA 2. If I look here at the DDL, I could see that that's SCADA FLaNK 2. Now I'm running the join here, so it may not be using that consumer group name. So we could take a look in FLaNK here to see what the consumer group name is. Make sure we're matching up. So when we're pulling things out of there, we see what's going on. These are things you might want to check. Make sure you don't have latency or losing data. Again, powerful system here. What's nice here with the dashboard, I can see all the different FLaNK jobs running. As you see, I didn't write any Java code. This Java code was built for me automatically with the FLaNK SQL, so it makes it very easy to write these apps, even though it's doing some pretty powerful work here for me. And again, if I want to use different sets of data here, I could just keep refreshing this, get the current, or maybe make a Python application that updates the data or updates a graph or chart every couple minutes or even seconds, depending on how fast you want that refreshing. Same with anything accessing the data as we store it, gets updated as we do it. You get that dashboard not working. Maybe look at a different sensor. We're pushing lots of different data to these things. And this is how we accomplish these type of apps where I have sources. I want to get them event at a time. Maybe I want them in a small batch, but often as soon as something happens, like the temperature got hot on a device, I want to know as soon as that event comes through the system. I don't want to wait for something to happen. Like here, as soon as that event made it to NiFi, I could take a look at that temperature and see if it's above certain temperatures. And I could have done this with Celsius. I could have done it with any of the sensors or any of the values to take a look. And here, if it gets above, if the temperature is trending up, I could send that over to a Slack group. See here, I've been had a lot of alerts, but I turned them off. I should have turned them back on, so I would have known, hey, it's getting hot in here. Might be time to turn on additional fans or air conditioned units. Those sort of processes are pretty simple. We could also, if we didn't want to go through all of this trouble, like maybe I don't want to do much with NiFi. Maybe NiFi is just being this listener. I could have done this right here and pushed this right to my broker, whether that was Kafka, Pulsar, Kinesis, anything else you have out there, and cut out that step. I probably want to do the routing, so I send just the ones that should go there. But I could have that topic dynamically defined based on metadata. As you see here, we're looking at the different metadata you can access. Could have used that to determine what topic to go to. Pretty straightforward. And I was talking about those Kafka Connect apps. Again, that's another way I can get data into the system. Pretty straightforward, and it's defined with a simple JSON, but gives you more options. Again, when you're using a complex system, start off small, get the data in a format that you need. once you have it in that format, validate it, clean it, get it into something like Pulsar so it can be distributed, and then write your continuous SQL on it. And that's the majority of apps you need there. All these systems are designed to scale out, and there's tools and guides out there in the open source to make that pretty straightforward. I'm hoping you enjoyed the talk today. If you have any questions, please reach out. If I'm not on the chat, I'm in the Apache Slack. I'm around. Thanks for joining my talk. I hope you enjoyed it, and see you at ApacheCon, the global event later in the year.